Hello students, subscribers, and viewers, and future engineers. Here is another video on indeterminate beams with support settlements solved in 5 ways. And this is the first way by the three moment equations. For those who are interested to solve this problem by your own, you may do so by pausing the video and not looking at the solutions first. Other problems next to this would be 10.4a by the slope deflection equations, 11.4a by the moment distribution method, 11.4b by the matrix approach, and 14.4 by the applications of matrix approach and the software RISA in order to verify the answers. But this is the first problem where I solved this in more detail. In the foregoing problems or solutions, we'll just verify the moments at A, B, C, and D. So if you want to know or to understand the solutions here, if it is your first time, you will hardly understand the solution here. But if you want, you first watch the lecture video, the derivation of formulas on the three moment equations. So determine all support reactions. Support downward movements are A 6 mm as shown, B 12 mm, C 9 mm, D 4 mm, and E 0. No support settlements at E. EI is 150 kilonewton meter square. So the three moment equation is for ABC, for example, is MA plus twice the middle point MB, quantity L of AB plus length of BC, supposedly over I, if the moment of inertia is not constant for each segment. Each L should be divided by I, then plus MB times LAB over IAB plus LBC over IBC, so MAB times 2, then plus MC times LBC over 2, plus 6 area 1A over E1 I1 L1, plus 6 area 2B over E2 I2 L2. The explanation of the calculations and formulas for those mentioned, 6 area 1A over E1 I1 L1 and 6 area 2B over E2 I2 L2 are in the lecture part of the three moment equations. Then equals 6 quantity HA over LAB plus 8 sub C over LBC, assuming EI is different for each segment. But if EI is constant, then the equation reduces to MA plus 2 times MB quantity L1 plus L2 or LAB plus LBC plus 6 area 1A over L1 plus 6 area 2B over L2 equals 6 EI quantity HA over L1 plus or LAB plus HC over LBC. So another technique is, since the support A is fixed, it is transformed into an interior pin and extended with negligible length and call that A prime. The moment at A prime, because it is an end support, is 0, of course. So we first establish the three moment equation on A prime AB, and this is the equation. Moment at A prime 0 plus twice moment at A, the middle point. Then quantity, since A prime A of negligible length 0 plus AB, length of AB 9 plus MB times 9 plus 6 area 1A over L1 is 0 because there's no load on A prime A. Then plus 6 area 2B over L2 is the value of 6 area 2B over L2, which is 7 over 60 quantity WL cube, 7 over 60 WL cube. So 7 over 60, 69 cube. Then equals 6 EI. EI is 150,000. The reference is the middle point A here. And the horizontal line through A crosses A prime. They are at the same level. So therefore, it's 0. H A prime is 0 plus H sub B, since B is below A by 6 mm, 12 minus 6 is 6 mm, so it is negative 0.006 meter over LAB, which is 9. Simplifying, the first equation is 18 MA plus 9 MB equals negative 5703. Call that equation 1. We then next write three moment equations on ABC. So we have A, B, C. Take note. So we have moment at A, interior pin, so there is moment expected, although the original is fixed, so there is moment expected. M8 times LAB, which is 9, plus 2 times MB quantity, LAB 9 plus LBC 7, then plus moment at C times LBC 7, plus 6 area 1A over L1 for triangular loading, and for from the farther end is 8 over 60 WL cube, then plus for this uniform load over the entire span WL cube over 4, the 40 times 7 cube over 4, then equals 6 EI, 150,000. The reference is horizontal line through B, so A is above B by 6, so positive 0.006 over LAB 9, plus C is also above the reference horizontal line through B by 3 mm, so positive 0.003 divided by LBC, which is 7. The value of this term is 6,900 over 7. This one is 3,430 and this one is 5,830. So combining the constants transposed to the right, then simplifying, we have 9 MA plus 32 MB plus 7 MC equals negative 57,934 over 7. Call that equation 2. Then we write three moment equations of BCD. So moment at B times 7 plus 2 times MC times 7 plus 5 plus moment at D times 5 plus WL cube over 4, 6 area 1A over L1, 47 cube over 4, then PB over L, quantity L square minus B square, so 50 times B, 3 over L, 5, quantity 5 square minus 3 square equals 6 EI. Reference is C, so B is below C by 3 mm, so it is negative 0.003 over 7. D is above C by 5 mm, so plus 0.005 over 5. This value is 3,600 over 7. This one is 480. This one is 3,430 combining. So 7 MB plus 24 MC plus 5 MD equals negative 23,770 over 7. Call that equation 3. And finally in CDE, and take note that the moment at D is 0. Moment at C times 5 plus 2 times MD, quantity 5 plus 6 plus ME, which is 0. Then plus 6 area 1A over L1 is 50 PA over L, quantity L square minus A square. So 50 times 2 over 5, 5 square minus 2 square. Then plus for this couple load, it is moment over L, quantity 3B square minus L square. So moment, which is positive because it is clockwise here, over L6, quantity 3B square, where B is the distance of this couple from the right, which is 4 minus L square, and equals 6 EI. Reference again is D, so C is below D by 5 mm, so negative 0.005 over 5, and E is above D by 4 mm, so positive 0.004 over 6. This is negative 300, the value of this term 360, 420, combining and simplifying, 5 MC plus 22 MD equals negative 1080, equation 4. Solving these four equations simultaneously using your calculator capable of solving four simultaneous equations, then linear equations, we get MA negative 228.883 kilonewton meter. So remember this. MB is negative 175.901 kilonewton meter. MC negative 83.930 kilonewton meter. And MD is negative 30.016 kilonewton meter. Then we apply these moments. Moment reaction at A would be RA and this moment reaction. So these are the directions of the moments, clockwise at just to the right of B, MBA, then counterclockwise at C because it is negative. So same. So considering AB, summation moment B equals 0, so RA times 9 plus 175.901 equals 228.883 plus the moment of the load 1/2 of 9 times 60 times 1/3 of 93. So that's the equation. So that's why RA is 95.887 kilonewtons. And also, we have to remember this value. Then, summation moment about A equals 0, RB left times 9 plus 228.883 equals 175.901 plus moment of the load 1/2 of 9 times 60 times 2/3 of 9, 6. So RB left is 174.113 kilonewtons. Considering BC, summation moment about C equals 0, RB right times 7 plus 83.93 equals 175.901 plus moment of the load 40 times 7 times 3.5. So RB right is 153.139 kilonewtons positive also. Therefore, RB is 174.113 RB left plus 153.139 RB right, and we'll get 327.252 kilonewtons. Summation of moment about B equals 0, RC left times 7 plus 175.901 equals 83.93 plus moment of the load 40 times 7 times 3.5. So RC left is 126.861 kilonewtons. Then we consider CD, summation moment D equals 0, RC right times 5 plus 30.016 equals 83.93 plus 50 times 3. So RC right is 40.783 kilonewtons. We can now compute R sub C, sum of RC left and RC right, so 167.644 kilonewtons upward. That's upward, that's not tension. Then DE, summation moment about E equals 0. Sorry, CD is equals 0, so RD left times 5 plus 83.93 equals 30.016 plus 50 times 2. So RD left is 9.217 kilonewtons. Then, considering DE, summation moment E equals 0, RD right times 6 plus the load 180 equals 30.016. So RD right is negative 24.997 kilonewtons. So R sub D is RD left plus RD right, and it is negative 15.78 kilonewtons, or RD is 15.78 kilonewtons downward. And finally, summation moment D0, RE times 6 plus 30.016 equals 180, and you'll get 24.997 kilonewtons, or simply summation forces Y, because there's no other load except this couple, so it is opposite to 24.997 downward or negative, so it is 24.997 upward. So that's it for this video. I hope that you were able to understand the explanations and the solutions.